Hello and welcome to this video on data types in Java. In this video, we'll be seeing about what is data types, the different data types in Java, and at last a broader understanding of these concepts. So let's dive in. Data types represent the type, nature, and set of operations for the value which they store. There are two categories of data types in Java, primitive and non-primitive. Primitive data type specifies the size and type of variable values. They are the building blocks of data manipulation and cannot be further divided into simpler types. There are 8 types of primitive data types in Java, namely boolean, char, byte, int, short, long, float, and double. We'll be seeing about them in depth in the next video. For now, we'll have an overall understanding of these topics. So now let us look at some of the examples of primitive data types. The first is boolean. A boolean data type can store either true or false. So to initialize, I give boolean a equal to true. So by this way, the variable a now stores the value true. The next is character. A character data type stores a single character. It can store both lowercase and uppercase. I declare char b equal to d and I give semicolon. By doing this, I'll be able to store a single character in the variable b now. We can also store the lowercase values in the variable. The third is integer. Integer has a wide spectrum of primitive data types that can be used. The classic one is int, c equal to, you'll be able to store some values, integers, which cannot be fraction or decimal values. So there are some variations. You can use short, d equal to 5, and you can have long e equal to 1 2 3 4 5 6 7. Simple. Each data type can store different ranges of bytes in the values from the values. We'll be learning about them in depth in the next video. For now, understand that int can store integer values inside them. The last is float. So now we'll be looking at floating point number. A floating point data type stores the values including their decimal precision. A floating point is used to express values involving fractional precision. It is of two types, float and double. Float is a floating point data type that stores values including decimal precision. For example, I store the value h is equal to 1.2 and you need to end with the value f for the system to understand that f is a floating value. Then you have double. So double data type is similar to float. The difference between the two is that the double is twice the size of the float in decimal precision. It is used to store decimal values of much bigger ranges. So now I'll have I equal to 3.40. We'll be learning about primitive data types in the forthcoming videos. The next type of data type is called as non-primitive data type. It is also called as reference data type. So non-primitive data types refers to instance or an object, meaning they cannot store the value of a variable directly in the memory. They store a memory address of the variable. Unlike primitive data types, which are defined by Java, non-primitive data types are user-defined. They are created by programmers and can be assigned with null. All non-primitive data types are of equal sizes. Now we'll be looking at non-primitive data types example through coding. So it's okay if you do not understand the topics completely because we'll be looking at them as separate videos in the later tutorial. First, let us look at arrays. An array is used to hold elements of the same data type. It is an object in Java and the array name used for declaration is a reference value that carries the base address of the continuous location of elements of an array. Meaning, to initialize an array, you need to have brackets, either mention the number of elements that you're going to have. For example, I am trying to hold 3 values of an array in the same variable a. So I can now associate those values by giving an equal to and then curly brackets and associate the values here. So since this array is of 3 elements, I am giving the values 1, 2, 3. It is completely fine if you do not give the value also. The arrays will be able to detect the number of elements that need to be allocated for this. If I want to print any of these values, I'll be giving a and bracket location of that value. So if I want to print 1, this is nothing but the 0th location of the arrays. So I'll be giving a of 0. The next topic is strings. The string data type stores a sequence or an array of characters. A string is a non-primitive data type but is also predefined in Java. So string literals are enclosed in double quotes. So to declare a string, I have to type string s1, the variable name, equals to, and within double quotes, whatever value that I give will be stored as a character array. So string is also a type of an array, but it stores the characters in a single variable. So to print the string, I just give s1. Coming to the third topic, classes. A class is a user-defined data type from which objects are created. It describes the set of properties or methods that are common to all objects of the same data type. It contains fields and methods that represent the behavior of an object. A class gets invoked by the creation of respective object. Basically, a class is a template or a blueprint out of which an object is created. So now I have a simple example over here in the top to explain class. So for example, if I want to declare a variable that has a student's details like ID and name. So I can associate that ID and name to a single variable name through a class named student. I can do that by now creating class student. I can associate the values by now declaring int id, which is nothing but an integer value data type is being assigned to id, and then associate string with the name. By doing this, now I have two variables that are associated with student. So what can I do with this now? What I can do is I can now declare this id as default 0, and if I can now try to print this value by associating student.s equal to new student. This is nothing but the declaration of a class, and we'll try to print the value of id of that particular student s through ids. So the next topic that we'll be looking at is enum. And enum, similar to a class, has attributes and methods. However, in contrast to classes, enum constants are public, static, and final, unchangeable, and cannot be overwritten. An enum cannot be used to create object, and it cannot extend other classes. But enum can implement interfaces. So to understand better, for example, I can initialize an enum level, and what kinds of levels can exist: low, medium, and high. So I just declare those particular values here. So with this, there are a lot of applications available. The next is interface. An interface is declared like a class, and the key difference is that the interface contains methods that are abstract by default. To understand better, there is an inbuilt interface available called comparable. So I'll just write implements comparable and student. So this interface is used to compare values of any data types and sort them and store them in the ascending or descending order. So, we'll be talking about this topic much later in the chapter. Each topic has its own chapters available in the following videos. We'll be dealing with them in depth and the commands that we use for them and how they are used in real world applications will also be explored. So to summarize, in this video we saw what are data types, the different data types available, primitive and non-primitive, and we saw some examples of primitive data type. We saw an overall understanding of non-primitive data types in this video.